All right, here are perfect problem 7 solutions for Math 65. We're asked to solve the following equations by factoring. Okay, so this first one, I guess the first thing you should do anytime you got an equation that you want to solve by factoring is look for a greatest common factor. That's not quite true. First you should set it equal to 0, which it already is. Then you should look for a greatest common factor. And what I think you'll notice is that all three of these terms have an x in them. So we could factor out that x and get 6x squared plus 11x minus 10 equals 0. And then this x out here we'll just ignore for a little while, just leave it like that. But on the inside we're going to try to factor this polynomial. See, because it's a trinomial whose leading coefficient is not 1, the method we have is to find two numbers that add to whatever our middle number here is, so add to 11, and multiply to whatever the product of the first and last number here is, so 6 and negative 10. 6 times negative 10 is negative 60. So what we have to do is find two numbers that add to 11 and multiply to negative 60. So you think about that for a little while, or one way to do it is to be like, all right, what multiplies to 60? 1 times 60 would work, 2 times 30 would work, 3 times 20, 4 times 15. There's kind of a lot of things that multiply to 60. 5 times 12, 6 times 10. Now I think we got all of them up to order and throwing in negative signs, but when you kind of look at this list, it will help you to figure out we want them to multiply to negative 60, so one of these will be negative, and add to 11. So I think if we pick these guys right here and make the 4 negative and the 15 positive, we choose 4 and, add to positive 11, negative 4 and positive 15. And let's see, those add up to 11 and they multiply to negative 60. So then what we do is we write this same trinomial here, except instead of writing plus 11x, I'm going to replace plus 11x with minus 4x plus 15x. And I think I left myself just enough room to do that. So instead of 11x, plus 15x minus 4x. And now we want to factor by grouping. So again, don't let this x throw you off. That's on the outside. We're not dealing with that anymore. We're just looking inside these parentheses. These first two terms have an x in common, and they also have a 2 in common. So you factor out a 2x. And what you're left with is 3x minus 2. Then these next two terms, we want to factor something out so that we're left with 3x minus 2. That something is a 5. So the inside factors like this. Again, we're leaving the x outside. Don't let those extra parentheses throw you off. Just put on blinders. We're just looking on the inside here. These two terms on the inside both have a 3x minus 2 in common. And if you factor that out from each of these terms, you're left with 2x plus 5. And now that we've factored out the middle, we don't need these outside parentheses, so maybe you could write x times 3x minus 2 times 2x plus 5 equals 0. So now we've completely factored this equation out, but we're still not done. The idea is we have something times something times something equals 0. So that tells us that either the first one is 0, the second one is 0, or the third one is 0. Maybe I'll write those next to each other. Let's see, from here, I get that either the first one is 0, or the second one is 0, or the third one is 0. Because the only way things multiplied together can equal 0 is if one of those things are 0. So this one's already done, but the other two we need to solve for x. So you could add 2 to both sides here and then divide by 3 and get x equals 2/3. Here you could subtract 5 from both sides and then divide by 2 and get x equals negative 5/2. So for our answer we end up with 3 solutions, either x equals 0, x equals 2/3, or x equals negative 5/2. maybe this, or this, or this. So we solved that first one. Now we got to do that 2 more times. All right. See, the second one, kind of the trick here is it's not set equal to 0, and these parentheses can kind of throw stuff off too. This doesn't look like something we know how to solve. What you want to do is take this x and distribute it through, so you get x squared minus 2x equals 35. And then set it equal to 0 by subtracting 35 from both sides. And then finally it's in a form that you can factor. See, so we have a trinomial whose leading coefficient is 1. So all we need to do is find 2 numbers that multiply to negative 35 and add to negative 2. I think if you try that for a little while, what you'll come up with is negative 7 and positive 5. So what this, now that we have it completely factored, we can solve it. This tells us that x minus 7 equals 0, or x plus 5 equals 0. So either x equals 7 if we add 7 to both sides, or x equals negative 5 if I subtract negative 5 from both sides. And we got some answers. All right, finally this last one, kind of a mess here. Let's see, first of all, it doesn't equal 0. So maybe we should add 2x squared to both sides and subtract 2 from both sides so that it's equal to 0. If you do that, you'll get x cubed. Let's see, I guess the order you write them in doesn't really matter. I'll leave it in the order they're written now to try not to confuse people. But we add 2x squared to both sides, so now it's on the left and it doesn't appear over here anymore. And we subtract 2 from both sides. Now it's on the left and doesn't appear on the right anymore. And get to here. And now we have 4 terms, and the only thing we know how to do when we have 4 terms is factor by grouping. The point I want to make, we saw this in an earlier perfect problem, is that if you rewrote this as x cubed plus 2x squared minus x minus 2, it'll still factor just fine. You'll get the exact same answer. But I'll just leave it like this. From these first 2 terms, I can factor out an x and get x squared minus 1. And from these next 2 terms, if I want to be left with x squared minus 1, I better factor out a 2. And so now I have 2 terms, and they each have x squared minus 1 in them. So I can factor out x squared minus 1, and I'm left with x plus 2. And then be careful, we're still not done here. We're pretty close to done, but this guy will factor 1 step further. It's a difference of squares, so we can factor it into x plus 1 and x minus 1 and x plus 2. And now we're in a form where we can solve. If we have a bunch of stuff multiplied together to equal 0, that tells us that either x plus 1 equals 0, x minus 1 equals 0, or x plus 2 equals 0. Solving this first one, we get x equals negative 1. Solving the second one, we get x equals 1. And the third one, x equals negative 2. So I'll answer something like that. And I guess that's the end of the perfect problem.